So now we will see the our next topic, design Azure network solutions. Okay, and in this we will see the VNet security and hub and scope architectures in our Microsoft AZ-305 infrastructure solution architect exam. Okay, so before we begin the today's sessions, let's quickly recap what we learned in our previous session or in our previous in previous week. So we cover the container, Docker, Azure Container Registry, that is ACR, Azure Kubernetes Service, that is
Yeah,
AKS,
Kubert.
Azure Azure Container Instance, that is ACI, Azure Container Apps, Microservices Architectures, Azure API Management, and Enterprise Container Platform. Okay. So most
Mm.
importantly, we learned the applications cannot communicate with the networking, whether running virtual machines, app services, AKS clusters, database, storage account. They all depend upon networking. So this brings us to one of the most and largest important AG305 domain, which is Azure Network Architecture. Okay,
Yeah.
so why today topic matters? So imagine an enterprise environment where the resource has a virtual machine, AKS cluster, database, storage accounts, app services. Okay, so the question arises: how do we they communicate securely? How do we isolate the workload? How do we connect the Azure to on premises? How do we control traffic and how do we secure access? The answer lies in the network architecture. As Azure
Mm.
Architect, networking decisions affect security, scalability, ability, compliance, cost. So almost every Azure Architect include the network considerations. Okay. So what are
Yeah.
the learning objective for today? So by the end of this session, you will able to learn and see and explore the design Azure virtual network. Okay, then we will see
Okay.
the and see or understand the subnet architectures. Okay, then design IP address strategy, then understand the network segment, then design secure network architecture and apply the enterprise networking patterns. Then also we prepare for some and look for some AG305 networking questions. Okay, and obviously we think like an Azure network architect. Okay,
Yeah.
so imagine a company moving its data center to Azure. Okay, so current environment will be web server, application server, database server, management server. Okay, so in data center, let me check. Okay, so in data center, these systems communicate through the networking. So when migrating to Azure, application requires what? Application. Let me write here. Application requires what? First is connectivity. Okay,
Okay.
then isolation, then
Mm.
security,
Mm.
then routing. Okay,
Mm.
so these are application required. Okay, so Azure Virtual Network provide this foundation. So what is a virtual network or VNet? So question is, what is virtual network or simply say VNet? Okay, so if we see, okay, look, so virtual and virtual network, that is VNet, is a fundamental building block of your private network in Azure. It's enable the resource to securely communicate with each other, the internet, and on-premises network. Okay, so if I simplify this, so a virtual network or VNet is Azure logical network boundary. Think of a VNet as your private network inside the Azure. Like it is very similar to your your office, corporate data center network. Okay, but host is in hosted in Azure. Okay, so virtual network provides IP addressing, like it's provide IP addressing. Okay,
Okay.
then it's provide
Okay.
routing. I think you know some basic of the networking.
Mm.
Okay, then it
Does it
provide
deal with VPN?
connectivity. Okay,
Does it deal with VPN as well?
yeah, VPN is another thing. Okay,
Okay. Okay.
that is very basic thing, and that is another thing.
Okay.
That is part of networking, but the VPN is not
No,
only
that's
the
good.
networking. Yeah.
Good to know. Yeah, that's fine. That's
Okay,
fine.
so these are the provided by the VNet. Okay, so why do we need a
Okay.
VNet? So without a VNet resource, without a VNet, right here, without VNet, resource will be resources goes to no controlled communication. Okay, an application cannot communicate securely, and with VNet, with a VNet goes to resources, then virtual network or VNet, then it goes to controlled communication. Okay,
Mm.
so please take a note of this and type in chat
Okay.
from chat. So networking. So in that case, with VNet, networking becomes manageable. Okay,
Okay.
so let's take some real world scenario. Okay, so imagine a global insurance company application has web tier, application tier, database tier. So and their recorder is
Mhm.
internal communications, network isolation, secure architecture, or hybrid connectivity. Okay, and the
Okay.
architecture foundation will be Azure Virtual Network. Okay, and so what will the VNet architecture? So VNet art architecture will be basic architecture of VNet. It is like Azure Virtual Network. Then it goes to subnet A, then subnet B, then subnet C, and so on. Okay. So what are the core components of the VNet? So component one will be your address space. So defines available IP addresses. Okay, uh, wait a minute. Okay, so yeah. So what is component one? So component one is address spaces. Okay, it's defined available IP addresses. Okay, like example, let me write here. Are you audible? I'm audible. Hello.
Hello? Yeah, I can hear you.
Yeah. Okay. So the address space will be 0.0.0 equal to 16. Sorry, not this. It will be 16. Okay. Now what is component two? So component two will be subnet. Okay. subnet. So logical network assignment example, what in subnet? So it's 10.0.1.0 slash 24. Okay, and same like 10.0.2.0 space 24, then 10.0.3.0 and so on. Okay, and what is component 3? So component 3 is resource. So example, VM, AKS node, databases, so which is connected to the subnet. So address, now explain, now let go into the address space. So one of the most important networking concepts. Okay, for example, 10.0.0, okay, 0.0/16, okay, which provide 65,536 IP addresses, okay, and which is available for all subnet allocations, which is available for all subnet allocation. Okay, and why the address planning matters? So poor IP address creates the problem later. Okay, for example, let's take okay, let's take VNet A, okay, which is 10.0.0.0/16, and let's take VNet B is the same. Okay, so what is problem? So problem are address overlap. Okay, and pairing and hybrid connectivity become difficult. So ITech must plan carefully. Okay, and what are the enterprise addressing planning examples? So what is the corporate standard or industry standard? So corporate standard will be like Azure Vision 1 is your 10.0.060, okay, and Azure 2 is 10.20.16, okay, and if I go with region 3, so it's become 10.30 0.0 slash 16 and so on. Okay, so what are the benefits? What are the benefits
Okay.
of that? So benefit will be predictability, scalability, easier routing. Okay, so it will be
Okay.
predictability. Okay, then scalability,
It's got to do the same.
then easier routing. Okay, and what is a subnet? So a subnet is a logic division of the VNet used to separate the workload. For example, 10.0.0.0/16 divided into 10.0.1.0/24. It will become 10.0.1.0/24 24. Okay.
So for VNet, it doesn't change like this one that says 10.2, that like the corporate standard, the
Mm-hmm.
Azure region that says 10.10.00,
Yes. Yes.
7.2, 0.00.
And
Okay.
so on.
Okay.
Okay. So this is
So
a
for
standard.
corporate standard, it varies. For
Yeah.
VNet, it doesn't vary.
Yeah. Exactly. And why use subnets? So imagine a web server, database management systems all in one subnet. So probably poor security, difficult governance, limited traffic controls. Okay, and subnets solve this. Okay, so what are the three tier architecture? Okay, that is very common in AZ-305 pattern. So the first one is like subnet, app subnet, or database subnet. So architecture will be, it start from internet, then it goes to the web subnet, then it goes to the application subnet, then it goes to the database subnet. Okay, and what are the benefit of the network segmentations? So it will provide you security which restrict the traffic, it will provide you governance which apply the policy, it will give benefit of scalability which add the workload in independently, and it also benefit in monitoring which, in which the uh, traffic patterns are tracked. Okay, and what are the Azure service IP address? So important topic will be Azure servers. Okay, like first four IPs and last IPs in every subnet. For example, 10.0.1.0/24, like which is usable addresses are reduced, so ITech must account for this. Okay, and subnet design example. So I enterprise architecture will be VNet. What are the, let me write here, subnet enterprise architecture will look like VNet, then it goes to web subnet, which is a part of, okay, then app subnet, which is a, let's say it will be 10.0.2, okay, 0.0.24, and third one is your data subnet, which is the 10.0.3.0/24, and if there is management, then it will be become 4. Okay, and so on. Okay, so just write it. Okay, so, and what are the resource placement strategy? For example, web subnet host on the web servers, app gateway, and app subnet host APIs, business services. Data subnets host skull to databases. Management subnet host skull to bastions or monitoring. So what will the architecture terms? It start from virtual network and goes to the web tier, application tier, database tier, management tier, and they are all combined. Okay.
Mm.
Now, let me, okay. Now, what are the common mistakes? Okay. So overlapping overlapping the address spaces, flat network architectures, no subnet segmentations, poor IP planning, no growth strategy, mixing productions and non-productions resources. Okay, are you audible?
Yeah, yeah, I can hear
Yeah.
you. I'm listening. I'm
Okay.
listening.
And So then what are the best practices? So best practices will be plan the address space early, avoid overlap, use subnet segmentations, designed for the growth, separate workload tier, apply zero trust principles, and standardize the architectures. Okay, and let's take the quickly AZ-305 perspective. So if question will uh, arise, organizations require workload isolation, so answer will be your subnet. And if the scenario arise for like future VNet pairing is planned, so answer will be avoid overlapping IP ranges. And if the question arise web applications and database tiers require separations, so answer will be multi subnet architectures. And if the question arise enterprise migrations require scalable IP planning, so answer will be your always proper address space design. Okay, now okay. So in our previous topic, we learned how the Azure Virtual Machine Network and Subnet provide the network connectivity, segmentations, address planning, isolation boundary. However, the another critical questions remains: just because systems can communicate, should they? The answer is not always. Enterprise architectures must enforce least privilege access, control traffic flow, network segmentations, security boundary. So this is where the network security group become one of the most important Azure networking services. Okay, so imagine a company hosts a web server, application servers, database servers. So inside Azure, without traffic control, everything can talk to everything. Okay, this creates a major security risks. For example, compromised web servers goes to the database access. Potential data breach. Architect must control the network traffic carefully. Okay. So what is the network security group? What or NSG? Okay. So a network security group or NSG is Azure layer 3 or layer 4 firewall like filtering services. It controls the inbound traffic, outbound traffic based on the source destinations protocol ports. Okay. Think of an energy as a traffic gatekeeper for Azure networking. Okay, so why do we need energy? So without energy, internet goes to all resource accessible, which is dangerous. So and with energy, it start with the internet, then it goes to energy rules, then it proves the traffic only. So it is secure. Okay, and what are the real world scenario? So imagine an online booking banking platform. So architecture will be, let me write here. So it architecture look like first web tier, then its application tier, then its database tier. Okay, and what are the requirement? So requirement is web server. Okay, which allow the HTTP from internet. Okay, so and if the application server, if the requirement is for application server, so it allows the traffic only from the web tier. If the requirement is database, so it allow traffic from the app tier. Okay, and the architecture solution will be NSG. So what are the NSG architectures? So NSG architect flow look like it start from internet. Okay, then it goes to NSG, then it goes to subnet, then it goes to resources. Okay, so these are the energy network architecture flow. Okay, and what are the core component of the energy? So the first one will be security rules, which define the traffic behavior, then priorities, which determine the rule for processing order, then actions allow or deny, then the directions inbound or outbound. Okay, so energies rule architectures, every rules contain the source port, destination port, protocol access, and priority. Let me write here NSG rule structure is source, then source port. Okay, okay, we are talking about the energy rule structure. So energy rules structures will be, it contain like 7 rules. Okay, the first one is source, then source port, then destination. Okay, then destination port. Okay, then protocol, then action, then priorities. Okay,
Yeah.
so these are energy rule structures. Okay, so let's take example. So if HTTP allows, okay, so now what is the energy processing logic? So Azure evaluate the rules like lowest priority number first. Okay, like priority 100, priority 200, priority 300. So rule 100 evaluate the first. And why priority matters? Okay, so rule A, allow TCP 443, their priority is 100. Rule B, deny all, their priority is 200. So HTTPS traffic allow because rule A processes the first. So energy architecture diagram is look like it start from internet, goes to energy, then web servers. So only approved traffic passes. Okay, and what are the energy at the subnet level? So most common enterprise pattern, the architecture will be like it start from subnet, then go to energy, then go to VMS, like your virtual machine. So what are the benefit of it? So it is centralized control, easier management, consistent security. Okay, let me write here benefit. So benefits of first one, centralized control. Okay, then second is easier management, then third is what, consistent security. Okay, and energy at what is the benefit of energy at NIC level? So can also apply directly to the network interface. For example, virtual machine 1 NIC goes to energy, which provide the resource specific control. Okay, so now let's take the AZ-305 exam, some examples. So Microsoft often test subnet level energy versus NIC level energy. So always remember, okay, subnet level is usually easier to manage at a scale. Let me write here. Subnet level is usually easier to manage at a scale. Okay,
Okay.
and what are the default energy rules? So Azure automatically create default rules. For example, allow network traffic, which is allow VNet inbound. Okay, which is allow VNet inbound. Okay. Allow Azure load balancer. So it will be allow load balancer inbound. Deny internet inbound. So it will be deny all inbound. So our text should understand these values. Let me write the second value. So this is for this is for allow VNet traffic. Okay. And allow Azure load balancer inbound. This is for allow Azure load
Okay.
balancer. Okay. And the third
Okay.
one is deny all inbound, which is for what? Deny internet bound. Okay.
Mm.
And what are the three tier applications examples? So it start from internet, then goes to web tier, then goes to app tier, then goes to database tier. Okay. And traffic requirement will be internet goes to the web allowed, web to applications allowed. Applications, let me write here.
Okay. Okay. Kitchen database. Okay. Seven.
Internet goes to web allowed.
Okay.
Ole. Then web to app is equal to allowed. Then app goes to database is equal to allowed. Then if internet goes directly to database, then it's not allowed. Okay, not allowed or simply deny. Okay. So energy enforce these rules. Okay. And what are the application security groups? So one of the most important African topic, like problem is traditional energy allow 10.0.1.4 to 10.0.2.7 difficult to manage. So solution will be application security group. Use logical names. For example, web servers, app servers, database servers. So AGS architectures start from web servers, AGS, app servers, AGS, and database servers, AGS. So let me write here AGS key look like start with web server AGS, then it goes to app server AGS, then it goes to database server AGS. Okay. So energy rules reference the group instead of IPs. So what are the benefits of AGS? So it is easier management, better reliability, reduced complexity, dynamic workload. Okay, and what are the examples rules? So if the source will be web server AGS, destination will be app service AGS, port will be 443, action will be allowed. Okay,
Okay.
now Now this become the much cleaner than IP based rule. Okay. And what are the enterprise architecture examples? So it starts from web edges, then go to app edges, then go to database edges. So applications can scale without constantly updating the energies. So a stateful nature of the energies. So very important exam topic. Energy are stateful. Example, client it goes to request, it goes to server. Okay. And which respond the traffic automatically allowed, no separate rule required. Okay, now what are the common mistakes and best practices? So common mistakes are allowing any traffic using IP address instead of AGS.
Okay.
Overlie the complex rules, no documentations, incorrect priorities, no segmentations. And what are the best practices? It apply the least privilege, use AGS, apply energy at the subnet level, standardize the rule, prioritize, monitor the traffic, review regularly, and use the infrastructure as a code, which is Terraform or Pulumi, okay, or OpenDo.
Mm.
So now what are the AZ-305 perspectives? Let's see some common scenarios. So if the scenario comes, web servers should communicate with the application server but not database, so answer will be always energy rules. And if the scenario will be traffic control should be based on the application's role rather than the IP address, so
Mm.
answer will be application security group, that is ASG. Okay, and if the scenario will be security rules must automatically allow the traffic, then answer will be stateful energy. And if the scenario will
Mm.
be look like centralized traffic filtering requires for subnet workload, so answer will be subnet level. Okay, now we'll see the next topic. Okay, so in our previous topic we learned how the network security group energy and application security groups ASG provide the traffic filtering within the Azure network. However, the enterprise architect face additional challenges, like how do we secure the outbound internet traffic, and how do administrators access the VM securely, and how do we eliminate the public exposure of the Azure service, and how do we implement the zero trust networking. This is where the Azure firewall, Azure bastions, and private endpoints become essentials. Okay, so
Mm-hmm.
let's imagine a global financial institutions which has a resource of the virtual machines, AKS cluster, storage account, SQL databases, okay, and key vault. Okay, so without proper security, it's look like it start from internet, then it goes directly to the direct access, and then Azure resources. Here, the risks increase significantly. Okay, so modern Azure architecture flow follow the zero trust principles, meaning trust nothing, verify everything.
Everything. Okay.
Okay,
Mm.
so it means what is zero trust principle? It says trust nothing but verify everything. Okay,
Okay.
this is the zero trust principle. Always remember in your exam, in your work. Okay.
Mm. Trust
And
nothing
what
but
is a
verify.
Azure firewall? So Azure firewall is fully managed, stateful layer 3 to layer 7 firewall services. So it provides the centralized traffic inspections, network filtering, application filtering, threat intelligence, logging, monitoring. So think of Azure firewall as an enterprise security gateway for the Azure workload. Okay. So why do we need Azure
Mhm.
firewall? Okay. So energy operates the primarily at layer 3 and layer 4. So IP and port based. So organization often require the URL filtering, centralized security, threat protections, network wide governance. So this is an Azure firewall provides additional capabilities. Okay. So what are the real world scenario? So imagine a banking applications which has a requirement of only approved website accessible, block malicious destinations, inspect onboard traffic, centralized security control. So architecture solution looks like the Azure firewall. Okay, so in Azure firewall architectures, it starts from internet, then goes to the Azure firewall, then goes to the virtual network, then goes to resource. So all traffic
Okay.
passes through the firewall inspections. And what are the
Mm.
firewall capabilities to network rules? So it's control the source IP, destination IP, port or protocol, which is very similar to the traditional firewall. And what are the applications rules? Okay, it's control the FKDUN, URL, and web destinations. For example, allow the let's take allow the github.com. Okay, and block the
Okay.
unknown site.com. Okay, So what is Azure Basin? So one of the most important Azure network service. Okay, so traditional virtual machine access many organizations expose the RDP 3389 and SSH 22 to the internet. So architecture will be it start from internet, then go to public IP, then go to the virtual machine. Like very risky. Okay. And what is the Azure Basin? So Azure Basin provides the secure browser-based VM access without exposing the VM premise publicly. Okay, so architecture will be flow from the administrator, then goes to the Azure portal, then goes to Azure Basin, then goes to the virtual machine. Okay, and what are the benefit of the Azure Basin? So no public IP on VM, no open RDP ports, no open SSH ports, and secure access and managed services. And what are the real world example? So instead of the internet goes to the virtual machine public IP, always use internet, then its flows go to the Azure portal, then Bastion, then VM, and which is much secure. Okay, like in lab, I will show you like how the VM work. Okay, so please remember it. And what are the private endpoints? So one of the most important, heavily tested AZ-305 topics. So what is the problem? So many Azure service expose the public endpoint. For example, a storage account, a SQL database, key vaults. So even with the security controls, public expose the increasing risks. So what will the solution? So in private endpoint, private endpoint assigns private IP addresses inside your VNet. So I detect without private endpoints look like applications, then internet, then a storage account. And I detect with the private endpoint look like application, then goes to the public IP, then to the storage account. So the traffic remains on the Microsoft private network. Okay, and what are the benefit of the private endpoint? So no public exposure, no connectivity, private connectivity, improve security, regulatory compliance, reduce attack surface. Okay. Okay, so what are the Azure private link? So private endpoint are built using the Azure private link. Like private link enable the secure access to the storage, SQL, key vault, app service, custom service through the private networking. And private endpoint access look like VNet. It goes to the private endpoint, then Azure service, which in which the traffic never traverses the public internet. And what are the zero trust networking architecture? So one of the most important modern architecture concept, traditional model. What are traditional model? Like, let me look like. So traditional model is inside network is equal to trusted. Okay, but with zero trust model, it is never trust and always verify.
Yeah.
Okay, got it? And what is the core zero trust principle? So it's verified the expressivity with authenticate the every request, lead privilege, grant the minimum permission, assume assume breach, design as if compromise the investable. Okay, and zero trust architectures like identity, conditional access, network controls, private connectivity, protect resources. And what are the zero trust component in the Azure? So common services are Microsoft Intra ID, conditional access, PIM, energy, Azure Firewall, Bastions, private endpoint, or defender for the cloud. Okay. And what are the common mistakes? So common mistakes are public IP on the productions VM, open RDP to internet, public storage accounts, no firewall governance, no private connectivity, ignoring the zero trust principles. And what are the best practices? So use Basin instead of the public RDP SSH. Use private endpoint for the PaaS services. Implement the Azure firewall centrally. Adapt always zero trust architectures. Enable monitoring and logging. Apply least privilege networking. Continuously review the security postures. Okay. And what are the AZ-305 exam perspectives look like? So if the scenario will be administrator required the secure access to the VM, without exposing the RDP to the internet, the answer will be Azure Bison. Okay. And if the storage account must be accessible only through the private IP addresses, so your answer will be private endpoint. And if the organizations require centralized outbound traffic inspections and URL filtering, the answer will be Azure Firewall. And if the architect must follow the zero trust applications, so answer will be combined identity, network control, and private connectivity. Okay. Now let's see the another topic. Okay, which is which is hub and spoke architecture. Okay, so in our previous topic, we learned how the architecture secure using the Azure Firewall, Azure Basin, private endpoints, private Azure Private Link, Zero Trust architecture. However, the modern enterprise rarely operate this single VNet. So large organizations typically have the production environment, deployment environment, shared services, security services, multiple regions, on-premises data center. So the next challenge becomes how do we all the network communicate securely? So this is where the hub and scope architectures, VNet pairing, VPN gateway and ExpressRoute becomes critical. Okay, so let's imagine a multinational enterprise. The resource has the Azure productions, Azure deployment, Azure testing, Azure shared services on on-premises data center. So without a networking strategy, it's start from the network complexity, then goes to security challenge, and then operational problems. So our tech need a scalable network topology. So one of the most important Azure enterprise design is hub and spoke architectures. Okay, so what is a hub and spoke networking? So if you see, the hub and spoke is a standard enterprise network topology in Azure. It efficiently route the traffic, standardize the security, and control the cost. Okay, and hub VNet act as a central point of the connectivity to on-premises network hosts shared like the Azure Firewall, VPN Gateway, and DNS server. And what is the spoke VNet? So peer with the hub to access the shared services. Spokes isolate individual workload. Example: HR apps, finance app, and do not natively communicate to each other. So if I simplify, so hub and scope is a network topology where the central service are placed in. Okay, like hub network, while workload inside the spoke network. Okay, and why do we need hub and spoke? So without hub and spoke, VNet A goes to VNet B, VNet A to goes to VNet C, and VNet B to VNet C. Complex mesh networking develops, difficult to manage. So with hub and spoke, a hub go at top of the layer there is hub, then it has a spoke A, a spoke B, and a spoke C, which is much simpler. Okay, now what are the hub networks? So that hub typically hosted the Azure firewalls, VPN gateway, ExpressRoute gateway, Bastion DNS, which is shared infrastructure. And what is Spoke network? So Spoke network typically hosts the applications, okay, database, AKS cluster, virtual machines, okay, which is the business workload. So hub Spoke architectures diagram looks like. Let me write here. Hub and Spoke architecture diagram look like. Hub it goes to spoke 1, spoke 2, and spoke 3, and so on. Okay. And what are the benefit of the hub and spoke? So it's centralized security. So firewall deploy once, simplify the connectivity, single routing model, better governance, centralized control, scalability, new spoke added easily. So what is the VNet peering? So one of the most heavily tested networking topics, like VNet peering allows private communication between the VNets using the Microsoft backbone network. And why we use the network pairing? Without pairing, VNet A, VNet B, no communications. With pairing, VNet A goes to private communication connections and then it goes to VNet B, like resource communicate privately. Okay, and what are the VNet pairing architecture? It starts from VNet A pairing, then VNet B. Traffic remains on the Azure networks. And what are the benefit of the VNet pairing? So it's low latency, high bandwidth, no internet exposure, or simple ITAC. And what are the exam tips for the AZ-305? So peers VNet must not have overlap addresses, like very common exam questions. Okay. Now, what are the hybrid connectivity? So many organizations are not fully cloud native. Okay, and resource exists in the Azure or on-premises data center. So hybrid connectivity connect them. What are the hybrid connectivity architectures? So let me write here. Hybrid architecture flow look like Azure, then it goes to secure connection, then it goes to data center. Okay, which is common enterprise requirement. Okay,
Okay.
and what are the VPN gateway? The simplest hybrid connection solutions. VPN gateway provide the encrypted connectivity over the public internet. Okay, and what are the benefit of the VPN gateway? So it is a lower cost, fast deployment, encrypted tunnel, and suitable for the many organizations. And what are the VPN types? So it is side-to-side VPN, which is most common. Like it's connect to the data center to Azure, and point-to-point VPN, which is remote user connect directly, and VNet to VNet VPN connect the Azure VNet. Okay, so these are the example of the VPN. And what are the limitation of VPN gateway? So traffic travels over the public internet, although the encrypted web performance can vary. For missions critical workload, architects often consider the express route. And so, what is the express route? Express route. So, express route provides the private dedicated connectivity between the Azure and on-premises environment. Traffic does not traverse the public internet. Okay. So, what are the express route architecture? So, express route architect is data center goes to private circuit goes to express route, then goes to Azure. Okay, why we use express route? So it is benefit of predict the performance, higher bandwidth, lower latency, regular compliance, private connectivity. Okay, so choose VPN gateway when the lower cost require a small to medium workload, fast deployment needed, development test requirement. And when to choose express route? When the enterprise productions workload, regulatory requirements, high bandwidth needs, and predictable performance required. Okay, so now what are the common mistakes? So common mistakes are overlapping the address spaces, flat network design, excessive mesh connectivity, no routing strategy, choosing spexes unnecessary, or ignoring the DR connectivity. And what are the best practices? So use hub and spoke architecture, avoid the overlapping IP ranges, use VNet pairing for the Azure connectivity, use VPN for moderate hybrid requirement, use ExpressRoute for the hybrid workload, centralize security in H hub designed for the growth. Okay, so let's take some AG305 perspective. So if the scenario will be multiple VNet required centralized security and connectivity, the answer will be hub and spoke architecture. And if question arise for the two VNet must communicate privately, then answer will be VNet pairing. And if the organizations require the encrypted connectivity over the internet, then answer will be VPN gateway. And if the scenario comes like financial institutions require the dedicated private connectivity to the Azure, then answer will be express route. Okay,
Okay.
so these are the uh, part of the EG305. Okay, so now we have completed one of the most largest and important AZ-305 domain. Okay, like designing Azure networking, hybrid connectivity, and enterprise network architecture. Okay, so networking is the foundation of every Azure solutions. Whether development is virtual machines, app services, okay, and AK services, storage accounts, SQL database, container performance. So everything depend upon the secure and scalable network architecture. So as a Azure architecture or cloud architecture, network decision directly impact on security, ability, performance, compliance, cost, scalability. Okay. So what we learned today, we uh, we uh, we learned Azure Virtual Network. Okay. Then we saw address planning. Then we saw subnet architecture. We also looked for energy, which is network security group. We also looked for application security group. We also looked for
Okay.
Azure firewall. We also looked for Azure version. Okay. We also saw the private endpoint and private link. We also saw the zero trust architecture. Okay, and we also see the hub and spoke architectures. Okay, and also looked for the VNet pairing, VPN gateway. Okay, and also we lastly we see the ExpressRoute. Okay, okay. So these are the today topics. So and this brings us to end of the this session. So today we learned how the Azure architecture design for the virtual network subnet, network security group, application security group, Azure firewall, Azure bastions, private endpoint, hub and scope architectures, VNet pairing, VPN gateway, express route. So the what are the key lessons? So key lesson is network is not just a connectivity. Network is a security, scalability, governance, and business enablement. Okay, so let me read.
You know,
Key
it says up and spoke. Is it bespoke or just up spoke?
hub and spoke. It is this.
Up
Let me
and
write here.
spoke.
Hub and spoke. Okay. Read the chat.
Okay, up and spoke. Okay, not
Okay.
okay. That's fine.
So
Okay,
what are the key
that's okay.
lesson? So key lesson is networking is not just connectivity.
Yeah.
Okay. Networking is security, scalability, governance. Okay. And very important, business enablement. Okay, so yeah, so before our next session, we you have to review the VNet designing, address planning, energy, Azure firewall, private endpoint, hub and spoke networking, VPN gateway, and spectrum. So these topic appears frequently in both AZ-305 certification exam and your Azure Solution Architect interview. So yeah, thank you for learning with me today. Have a
Thank you
good day,
so
and we will see
much.
you next day. Okay, bye bye.